Hi, welcome to this video on the Future Internet course. Remember that we were seeing the SDN part and we already saw the introduction to SDN, a little bit of history of SDN, and also the separation between the control plane and the data plane. And now we are going to see here in this first video of how to go from theory to practice. And we will see the first steps with Mininet, which is the emulation, let's say, environment in which we can make some SDN programs, SDN applications, and have, let's say, play a little bit with SDN. So in the agenda, we will see Mininet, experimental learning for networking in general, the architecture of the emulator of Mininet, and then the basic usage with CLI and with APIs. And then the topology, we will see, we will have a topology exercise during the class. We will see how to do a linear topology in SDN, and then an exercise for you will be to actually implement a fat trip topology in SDN. So what happens with normally with the learning for networking when it comes to experimentation? The normal in engineering in general, learning by doing is memorable and leads to mastery. And you become more expert in a topic when you can learn by doing things, right? And in computer system courses, this means building, modifying, using, and experimented with working systems in general. In networking is a field in general in distributed systems, but particularly networking is a field in which the courses require actually complicated testbeds, including multiple servers, switches, and routers to have experimental scenarios or experimental settings in which you can test what you already learned in the theoretical classes. So the idea normally when you go to a lab in a networking course is that you have a lab that is already, let's say, a network that is already wired and connected. And a hardware test bed is always with equipment from manufacturers, and then you learn how to configure the equipment of the manufacturers using their operating systems and so on. So it is expensive. The disadvantages is that it's expensive. The resources are not sure. This is hard to reconfigure. When you already make a configuration, then you have to reconfigure. If you want to reconfigure something, you have to reconfigure the equipment one by one. It's also hard to change and hard to download. The advantage is that it's already, of course, fast and accurate. I mean, when you have what you have there is actually what it really happens in the real world when you configure a network. Another alternative is to make the experimentation by means of simulation. So if you have a simulator, like for instance NS2 or NS3, it is inexpensive. The advantage is that it is inexpensive, flexible, easy to download, and in virtual time can be even faster than reality. But the disadvantages is that it may require app changes. It might not run real operating system code. It's not running the real thing that is running actually in the real equipment. The accuracy maybe is not good, and this is a very, very big drawback. I mean, it's when you make a simulation, maybe it's not as accurate or is very different to what happens in the real system, right? So it may not be believable, and it also may be slow or non-interactive. So and sometimes also very hard to program. I mean, for instance, to program a simulation in NS2, you first have to learn. And the learning curve, I think, is a steep in this kind of simulator. So maybe the implementation can be slow and very difficult to interact with the system. In contrast, the alternative of emulators is not very well explored, I think, in the networking field. Emulators are also inexpensive, flexible. The main advantage of emulators is that you run real code of the real equipment, the same that if you were using real equipment. It's reasonably accurate, so the accuracy of the results of the emulator can be even better than the ones of the simulator. Easy to download, fast interactive usage. Of course, it's not the same as having the real hardware, so the experiments can be slower than in real hardware. And maybe because of that, the accuracy is not that big, but the accuracy will be bigger than the one of the simulator, because we are running actually real code as if it were running in the real equipment. So an emulator is a very good alternative in terms of costs and in terms of accuracy and performance uh, when it comes to go to the experimentation part in networking courses. So let's see, for instance, if we want to do an emulator of a very simple network. Look at this network where I have one switch and two hosts attached to the switch. One host is running let's say a web server, and the other one is running a web browser to make the connection. And let's think that we want to emulate this. If we want to emulate this, for instance, in a Linux system, in a Linux host, then what you can do is actually to create a container or a virtual machine for this switch, another for this host, another for this host. You can put this virtual machine or this container to run as a virtual switch, and then connect the two virtual hosts to this switch, and then run the experimentations you want. And this is actually easy to do, easy, but not easy, but doable actually in Linux. For instance, in Linux platforms, where you can have virtual machines, or actually virtual machines running as switches or hosts or whatever you want in in containers, and in the small containers that are very light, that does not have a big size in terms of memory or hard disk and so on. So you can run actually very big networks in a Linux system. So the code to implement this such a, let's say, simple network is something like this. I'm not going to go into detail, but this is actually what you have to do to add a host, to add a virtual switch, and to configure the interfaces with the IP addresses, and to connect the interfaces of the hosts to the switch. And then if you want to have an SDN approach when you have a controller, also to create a controller and so on. So you need a big set of commands to do it. And here actually I am not even creating the web server in one of the hosts, or working with the web browser in the other one. Right, so you need kind of a set of commands. But what if this is already done for you? What if we had a simple, very simple command line tool and or API that does this for us automatically? And also, what if it allowed us to easily create topologies of varying sizes, up to hundreds, so created actually big networks and run tests on them? And what if it was already included in some Linux distribution, like for instance Ubuntu? So if this happens, it would be very good, right? It would be great. And this is what Mininet is actually. Mininet is like an emulator that allows to easily create containers in Linux and connect them by using virtual switches that actually support the OpenFlow protocol, which is actually a protocol for SDN. So they support SDN. So it's easy to create controllers, virtual hosts, virtual switches, and connect everything in a topology that actually can be customized by the one that is by the programmer, by the implementer. So it's easier to create or to have all the emulation platform in this way. So Mininet is like an emulation platform for you to create any network that actually can also use SDN to be controlled. So there are several ways to use Mininet, the command line interface, using an API with a Python application, and it also have a graphical user interface, which is not very used because it loses all the flexibility that you can use in the command line interface or using the Python API. Okay. These are command line interface options. -H to display the help of the Mininet, -C, that is the same than -clean to clean the topology, and so on. In the next video, we will explore all the command line interface. We will also explore the Python API that you can use with Mininet, and we will then see how to create a linear topology and put an exercise to create a fat tree topology for you. So thank you very much for your attention, and then we will see how to use actually Mininet in the next video.